A very warm welcome, dear students. In today's session on my classroom, we will be looking at the flip side of the most important form of a straight line, slope intercept form. What is slope intercept form? Any line having slope m, and y-intercept c, the line equation will be of the form y is equal to mx plus c. It's a very simple form, very useful form, especially in calculations, because of the simplicity, and there are only two unknowns here, m and c. Okay. So, instead of the general form, this is very handy to use, but it comes with a flip side. What is that flip side? When we are using the word slope, slope is tangent of inclination, tan theta. Whenever theta is 90 degrees, the term slope is not defined. So, slope word, whenever it is applicable only for non-vertical lines. Slope word is applicable only for non-vertical lines, and hence slope intercept form is also useful only when you know there is no non-vertical line, or when you are talking, when there is no vertical line, or when you are talking only about non-vertical lines. So, slope intercept form is useful for non-vertical lines. But in applications, what happens is, you don't know before solving the question whether there is any vertical line involved or not. Let us see how this matters in applications. Just let us look at an example. Find equation of tangents to the circle x square plus y square is equal to 25 from the point, drawn from the point 5, 6. Drawn from the point 5, 6. We know simple. If the point is on the circle, you will have two tangents. If the point is inside the circle, you will have no tangent. If the point is outside the circle, you will have two tangents. So, is the point inside the circle or outside the circle? Just substitute 25 plus 36, 25 gets cancelled, 36 is a positive number. So, the point is outside the circle. So, technically you should be getting two tangent lines. Let us see how we work out this question. We will assume the tangent line in the slope intercept form. What is slope intercept form of tangent equation of a circle? Y is equal to mx plus or minus a. If a is the radius, a root 1 plus m square. So, here radius of the circle is 5. Y is equal to mx plus or minus 5 root 1 plus m square would be tangent equation. Now, what is significance of this tangent? This is a tangent drawn from the point 5, 6. So, when you substitute 5, 6 in this equation, it should satisfy. Let us substitute 5, 6 in the equation. So, y coordinate is 6, x coordinate is 5. You have simple equation, 6 is equal to 5m plus or minus 5 root 1 plus m square. This 5m we will take it to the other side and square on both sides. 5m you take it to the other side and square on both sides. So, squaring, what will it give you? 25m square minus 60m plus 36, 25m square plus 25. You can see 25m square here getting cancelled. You are left with a linear equation. 60m is equal to 11, and you will get the value of m to be 11 by 60. 11 by 60. Now, you have one value of m. Here, with one value of m, I am getting two signs, plus minus, but only one of them will make sense, the other one will not be applicable. Let us see how. So, substitute the value of m is equal to 11 by 60 in this particular equation. 6 minus 5m is equal to 5 root 1 plus m square. 11 by 60, 6 minus 11 by 60, is it a positive number or a negative number? 6 minus 5 into 11 by 60 is a positive number. So, I cannot use minus sign here, I have to go with plus sign. So, I will have only one tangent sign in this equation. I will have to use only plus sign, not the minus sign. So, there is only one tangent line from this process, but the point is outside. So, how many tangent lines you should get? If I draw the figure, 5, 6 is a point outside the circle. There are two tangents. Now, one tangent already I got with slope m is equal to 11 by 60. Where I missed is the other tangent line. Why? If you observe the point 5 comma 6, x coordinate is 5 equal to radius. So this tangent line is a vertical tangent line here. This tangent line is a vertical tangent line here. That is the reason instead of getting two tangent lines, you got only one tangent line. So how to identify such in this process itself? Theoretically, whenever m square is getting cancelled, it is not a quadratic equation, it is a linear equation. But somehow you can tell yourself that there is a infinite root possible, because this m square coefficient is becoming 0. There is nothing called infinite root, but you have to be cautious that whenever you are getting 25 m square cancelled, there is a possibility of that infinite root. Okay, that m being infinity. That is when you have to check whether there is any vertical tangent possible or not. Okay, so this will save your marks and this will save you from not committing any mistake in the question. This is a very important model of question. If you like the video, like the channel, like the video and subscribe to the channel. Wish you all the best.